going to talk about the 2,246 longest path with different adjacent characters. The question is, you are given the tree, a connected undirected graph that has no circles, rooted at node 0, consisting of n nodes numbers from 0 to n minus 1. The tree is represented by a zero index array parent of size n, where parent I is the parent of node I. Since node 0 is the root, so parent 0 is equal to the minus 1. This is minus 1. And you also given the string s of length n, where si is the character assigned to the node I. Return the length of longest path in the tree such that no pair of the adjacent nodes on the path have the same character assigned to them. So longest path where each two adjacent nodes have different character in the tree, the path 0, 1, 3. The length of this path is 3. So 3 is the return. It can provide that there is no longer path that satisfies the conditions. Let's see. So how could we do this? We have the parents, right? So parents means 0 here. And this is kind of called, like, I will treat this called a level. Let's see here. This problem got a little hard to understand. The parent is 3, right? Minus 1, 0, 0, 1, 2. And this is the string s is equal to this one. So the index is 1, 2, 3, 4, 5. You can see here, the index 0 means the parent, so it's minus 1. And for here is 1, so this actually means the level. And the 1 means match to the here, right, B. So we need to create use like DFS, right? But we need to use the map to store the neighbors and to find current now what is the longest. And then return, we also need a global readout to track maximum. Yeah, you can see these neighbors, you have this one and this one, this one. So it's kind of like for 1, we have the 0, 3, 4. So we have the 3. So we need to return the maximum this way or this way, this way. So you can see here the neighbors is like, is what? 0, 1, 3, right? This is the maximum. And also need to check there's some conditions for this hard problem. So some hard conditions like their neighbors cannot be the same. You can be the AAE, so this is wrong, right? So we need to return the results. You can see for here this minus 1, and the longest should be the 3. How could it be 3? It's 2, 0, 3. This one cannot because it's so we cannot treat it as like a tree. It's more like, I would say, treat like a graph. Let's see. So it's I have global. Go to the because the first one I want to return like left tree, right tree, and so this one don't need to do that. Have the map. And there's lots of neighbors. put if absent. Put if absent, right? So for this, put if absent is like put this integer I list. Get index I and put the we find that one, so we need to parent I. No, wait a second. I means we need to search the parents, right? Like the node 1 means parent 0, how many neighbors it is. It's okay. DFS like start from the 0. The graph S. Turn the results +1. Why this +1? Because we didn't calculate 0. We just calculate the DFS purpose for this left tree, right tree, right? Okay, so if S is equal to the if the graph not contains we don't do anything, just return 0. List the neighbors. Get I. For interchase. For the size. Say nest is equal to the neighbors graph get J to check these neighbors, and neighbors will return also some list, right? So we can get some like current length of the DFS like I graph S. Should start from the nest. Okay, so we got the nest one, right? So we have the result. Need to +1, so result should be maximum. It should be the length. Also need to check if because neighbors, we also check the character. So if the schar at I is not equal to the next one, can do this. If not, we need to return the turn 0. We can check. Graph get neighbor again. Oops. So we have the maximum length array. But this one means the same character. See. Yep, and for the time complexity, still be the TC is O(n) and space should be the O(n). I will create this one. We can check. Thank you.